When do you want to say fast? Next test.
Next Saturday, ma'am.
Can't hear. All of you say. And the common
Next Saturday.
Saturday. Okay, so
Next week.
Saturday, P block, I don't think we will be able to. P block is a big chapter and I am going very slow because it is an important chapter and it is difficult to learn. Understanding is not, you can understand yourself. Not next week. Palak, don't push me that hard. Hmm? This Saturday. Haha. Next Saturday. Why, Palak?
Which chapter, ma'am?
Next Saturday means coming Saturday. P block. Okay.
Okay.
Okay. So then we will continue. Last class. Yesterday I did not take at all. Oxygen. We completed oxygen, isn't it? And so the next is oxides. So oxides, you don't have, I will tell you to mark in the book. You just listen. You don't have to write the notes. Okay, it is an easy topic. Too much to study this week. Why too much? Every week it will be too much, no? Many tests. Every week, everybody should give test. That is ma'am's order. So every week it will be there. So Saturday, any test is there? And then you are learning. I make you the equations, learn in the class, and then daily learning, 10-15 minutes you spend, that is enough. That you are not doing. And you are just ignoring me saying that. Saturday, any test is there? Are you having any test on Saturday?
This week, no test, ma'am.
No. So then I booked 1 day, 1 test. Okay? So you have to do, children. Otherwise, you are in class 12. So much to learn. It will be like that only. Next week also, every week we have to give test. That is what ma'am is saying. No. What? Okay. Palak. Many tests, but Saturday nothing is there. Na? Friday you sit and study. And what we are learning now, maybe if you are lucky, I don't think we will be able to complete this chapter. Okay. So every Saturday. So we have IP and chemistry. Pushpa ma'am hasn't given now, na? Tell her to take on Monday. Saturday I am taking. See, na one test per day. You have to say that. Whoever, see, last week I shifted the Saturday test to Monday, na? Whoever says first will get. Okay. So I am taking on Amitav and Ruchi, and who will add this IP, na? So you tell that chemistry test is there. Chemistry in every day. Pankaj, you got 8 or 10 marks. You will get from me, okay? Not a chemistry in everyday life. That will be later. Okay? And that chapter also difficult. It is not that you will get if you ask your seniors, they will say that chapter only they lose mark because properly you have to study that chapter. Anyway, it will be P block on Saturday. Okay? And see, I am willing to take on Monday also, but most of the children are saying on Saturday. That is why that you decide among yourself, and so it will be on Saturday. Okay, so oxides, next topic, and you listen carefully. It is a very simple topic, and I will make you mark in the book. That is enough. Oxides are of two types: simple oxides and mixed oxides. Okay, simple oxides like FeO, only one oxide, isn't it? And a mixed oxide example you will understand. Fe3O4 is an example of a mixed oxide, and that is a mixture of FeO and Fe2O3. Sorry, Fe2O3. Okay, so Fe3O4 is a mixed oxide. Have you understood? And so, have you understood the difference between a simple and a mixed? I will write it on the board. Example of a mixed oxide. this is an example of a mixed oxide. Why mixed? Because it is a mixture of Fe, isn't it? FeO and Fe2O3. So it is an example of a mixed oxide. And similarly, Pb3O4 is another mixed oxide. Have you understood? Okay.
Ma'am, could you explain that once more, please? I lost my connection.
See, I wrote an example of a mixed oxide, Fe3O4. Why mixed? It is a mixture of two oxides, FeO and Fe2O3. Okay, so that is an example of a mixed oxide. Now coming to simple oxide. FeO is a simple oxide, means only one oxide is there. Okay, so simple oxides are of four types: acidic oxides, basic oxides, amphoteric oxides, and neutral oxides. Okay, so acidic oxides, the oxides which when react with the water gives an acid, is an example of an acidic oxide.
Carbon dioxide.
Carbon dioxide, SO3 plus water, H2SO4, SO2 plus water, H2SO3. So these are all SO2, SO3, carbon dioxide. These are all acidic oxides which react with water to give an acid. So which are basic oxides which react with water to give a base, calcium oxide. CaO plus water is CaOH twice. That is an example of basic oxides. Now, which video for everybody video is not clear? Board you are not able to see, Prashant? What is the problem? For everybody? Okay, can you see the board now? Prashant? Okay, so you see the board. I just wrote the example of a mixed oxide. Now is it clear, Amitav? Okay. So I just said about the simple and mixed oxide on the board. I just wrote and explained how mixed oxide is coming. Then after that, I was saying only about the simple oxides, acidic oxide over basic oxide, calcium oxide plus water, you get a calcium hydroxide, you will get a base. So it is an example of a basic oxide. And then coming to amphoteric oxides. Amphoteric oxides have characteristics of both basic and acidic oxides. In other words, they react both with acid and base. Aluminium oxide is an example of an amphoteric oxides. So you have to, if they ask about amphoteric oxides, you have to write reactions of amphoteric oxides with acid and alkali, base. So they have given aluminium oxide, and they have given reactions of aluminium oxide with HCl and NaOH. So that is little difficult, that I'll write how both of them react. How aluminium oxide reacts with both acid and base. Okay, so that equation I am going to write. See the equation. I am giving you time. That time don't look left and right. At that time you study. And see, equations are such that when you study, you feel that you know, but then some children are slow, some children are fast. The faster, smarter children, what you have to do, you have to again and again write so that you can save time. Okay, so the equation I am writing, you are going to write now. I will give a few seconds only. That much is enough. Most of the children will learn if you pay attention. Okay, so what I am going to, Anand.
Ma'am, NO2 is an acidic oxide, right?
NO2, sodium. Sodium.
NO2. No, nitrogen dioxide.
Yes.
Okay.
Nitrogen. That side of the periodic table, there's non-metals. Normally, non-metals form acidic oxides. Metals form basic oxides. Okay.
Okay.
So now Al2O3. This has properties of both acidic and basic oxides. So it can react with both acid and base. So the reaction of Al2O3 with HCl and reaction of Al2O3 with NaOH, that I am going to write. So that proves that it has properties of both acidic and basic oxides. So any question related to that or amphoteric oxides, you have to write that. Okay. So board is clear. Here, listen carefully, and when along with me, you learn. So the amphoteric oxide is aluminium oxide. I will write from here. Aluminium oxide. And the first reaction is with HCl. HCl plus water. So you will get Al, H2O, 6 times 3 plus Cl minus. Here it is actually number. You can learn the number, it is easy. 6 HCl, so 6, 2 and 9 water. So some reactions it is easy. Otherwise getting this 9 number and all takes lot of time. So you look at the board. This is alumina with HCl, water is there. Even with NaOH, water is there. And this complex you have to learn by heart. This is formed. Al, H2O 6 times, 3 plus. Aluminium charge is 3. Water is neutral, so no charge. Plus 6 Cl minus. Learn fast. Okay, learn and write. Only one time writing is not enough. And tell me how many who all learned. Oh, see, smart children done. Saurav, good. Alak, good. Right. And so keep on writing, children. Prashant, Chinmaya, Varshini, all are smart. Good. So keep on writing. You don't stop. Agnel, very good. Kirtana, good. So this is enough. Then together 2 equations I will give another time. Jai, where are you? Pankaj, Abhishek, where are you?
Yes, ma'am.
Done. Board.
Writing, ma'am.
What is Jai?
Doing, ma'am. 1 minute.
Just learn by heart, write many times. Those who finish also write again so that you don't have to learn again. Okay. So now the next one also I will write. You can practice with NaOH. So Al2O3. I said these are the things you should remember. Water is there, and this you cannot guess. You have to. So here in inorganic, mostly learning by heart. So you will get this complex Na3 Al OH 6 times. Okay. So 2 aluminium is there. You have to put 2. So then it becomes 6 NaOH. And then here hydrogen is 6 into 2, 12. 6 are here. So 3 here. Okay, so now both you learn both, and then we will move to the next. See, somebody did both together. Very good, Prashant. Okay, keep writing, Prashant. Don't leave, okay? So some children have already, those who have done, write again. And so learning over, you are saying you don't have time. Keep a rough book and learn. So both together, who can write? Let me see, both together without seeing. Both together, Amitabh. Very good. Okay, so we will move to the next topic, children. Very good. So two equations only today we learned. And so the next type of oxide is neutral oxides. Neutral oxides, they don't have neither acidic nor basic. So carbon monoxide, NO and N2O. Okay, neutral oxides, carbon monoxide, and 3 examples learned for 1 mark. Carbon monoxide, NO and N2O. Okay, so that is oxides we have done. Next is ozone, which is a very important topic. And about ozone, you know that ozone is formed in the upper atmosphere, isn't it? About 20 kilometers from Earth, upper atmosphere, it is formed, and it is a protective cover from harmful ultraviolet radiations. All that story you know, isn't it? And so here the formation of ozone is endothermic. Ozone is formed from oxygen. And in the lab, if you want to prepare ozone, you have to, in the lab, to prepare ozone, you have to pass a silent electric discharge through oxygen. You have to pass a silent electric discharge through oxygen. I will write the equation.
Is there a coordinate bond in ozone?
Where? This one.
No, in ozone, ma'am.
Ozone. Yes, one is a coordinate bond. Structure when I teach, I will tell. Okay?
Okay.
So, oxygen from oxygen O3. So, this is the reaction. Okay? You can see.
Yes, ma'am.
Okay, so the reaction is endothermic. Okay? Silent electric discharge means, so that is what I am coming to that. You have to apply a very high voltage. The voltage should be very high. If it is very high, you don't hear any sound. That is why the name comes. Why do you have to apply very high voltage? Because the reaction is endothermic. Okay, and another reason in the book they said endothermic, and if you don't apply very high voltage, if you don't apply silent electric discharge, the ozone will decompose. Okay, so you will get, can't we heat? No. It is electric discharge. It should be very high. And that also not normal voltage, very high potential you have to apply. Okay, when we do that, and it is done in an apparatus called ozonizer. You will get a 10% ozone only. So it is done in an ozonizer, and you will get a 10% ozone. Okay, and if you want higher concentration, more than 10% of ozone, you have to use a series of ozonizer. You can see now me. So now clear? Okay, so you have to use a series of ozonides. Now, in the case of ozone, I said formation of ozone from oxygen is endothermic, but decomposition of ozone is exothermic. Decomposition of ozone is exothermic. Heat will be liberated. So delta H is exothermic, means delta H negative, and decomposition of ozone reaction, it is the entropy is positive. So the Gibbs energy will be large negative. And so the reaction is spontaneous and explosive. It is that much energy is liberated. Gibbs free energy is large negative. So that is understood. Decomposition is exothermic. You have to say, yesterday one question was there for zinc oxide, even though I gave the note and you did not attempt, many of the children did not, very few, those who learned and came only attempted, that is zinc oxide. And they asked in the liquid state, it is more easy. You have to say in terms of liquid state, entropy is more. So delta G is negative. Some children wrote delta G negative. That is not enough. Liquid state, when they say, you have to say entropy is more. Isn't it, children? And so you are not learning and writing the test. And that answers I gave notes. If you go through the notes, that is enough. Only Vishnupriya, Ruchi, and some who else. That is it. Nobody else learn and write. So coming to this point, the decomposition of ozone is exothermic. You have to say all the points. Don't say just Gibbs free energy is negative. So this decomposition is dangerously explosive. That much Gibbs free energy is liberated. And the reason you have to say delta H negative, because the reaction is exothermic, and delta S positive, so delta G will be negative. Clear? What, Anand?
I didn't get why delta S is positive.
That reaction is accompanied by increase in entropy. You have to say like that. Decomposition of ozone, it is accompanied by increase in entropy. Okay? And
What increases the entropy, ma'am?
Increase in entropy. If you see, what do you get? Decomposition by ozone, O2 and oxygen, two particles form. Number is more, means entropy will increase. Isn't it, Anand?
Yes, ma'am. Got it, ma'am.
You got the point?
Yes, ma'am.
So there is increase. So you take the textbook. You don't have to, what is given in the book, that is you have to write. Okay? So preparation. So you see, when a slow dry stream of oxygen is passed through silent electric discharge, instead of that, in simple sentence you can write, ozone is prepared in the lab by passing a silent electric discharge through oxygen in an ozonizer. There is a apparatus. You want that sentence? Ozone, you can write it over there in the textbook or in the notebook. Ozone is prepared in the lab. Ozone is prepared in the lab by passing. Ozone is prepared in the lab by passing a silent electric discharge. That is important. Silent electric discharge. By passing a silent electric discharge through dry oxygen. Through dry oxygen in an ozonizer. In an ozonizer. O-Z O-N-I-C-E-R. Ozonizer. In an ozonizer. Okay, silent electric discharge is used. Silent electric discharge is used to prevent decomposition of ozone. Got it? So next one, they said pure ozone is a pale blue gas. And if you cool it in liquid air, it becomes a dark blue liquid and then a violet black solid. Okay. That they did not write over there. You can write. How do you get it? Ozone is a pale blue gas, dark blue liquid, and violet black solid. You may be thinking how all these are possible. Actually, it is a pale blue gas. When you cool in liquid air, then it will go to liquid and solid state. Okay. And so if you inhale ozone after a particular limit, it causes headache and nausea. And so now the next paragraph you will underline and learn. Note is not required. That paragraph is very important. Ozone is thermodynamically unstable, and since its decomposition results in the liberation of heat and increase in entropy, all of you underline that. These two effects results in large negative Gibbs free energy. And so ozone is high concentration of ozone is dangerously explosive. That is the question. It is a board question. Give reason. High concentration of ozone is dangerously explosive. Understood, all of you? Okay.
Yes,
And
ma'am.
so next point.
Ma'am, that previous sentence, could you repeat? Silent electric discharge is used to
Prevent decomposition of ozone. Yes.
Thank you, ma'am.
Yes, Palak. In simple sentence, you can write. Palak, not that same sentence, but the point should be there. Okay? Okay. So, next point, ozone is an oxidizing agent. So, give reason, they will ask why ozone acts as an oxidizing agent. Because on decomposition of ozone, it decomposes to O2 and atomic oxygen, O. So due to the formation of atomic oxygen or nascent oxygen, it acts as an oxidizing agent. So that is the next sentence. Due to the ease with which it liberates atoms of nascent oxygen, it acts as a powerful oxidizing agent. Instead of that, you can write that it decomposes to give, it liberates oxygen. That is enough. And write the equation O3 giving O2 plus O. That is important. That you have to write. Okay. So it liberates nascent oxygen. Nascent oxygen is what? Atomic oxygen. That is why it is used as a powerful oxidizing agent. Now the next two reactions are very important. Show that ozone is a powerful oxidizing agent. Or they may ask you to complete the equation also. Both you have to learn. So the first one, before writing the equation, you should know oxidizing property of ozone. Lead sulfide to lead sulfate, and byproduct is oxygen. You learn that by heart and then only start writing the equation. Okay. So the first one is lead sulfide to lead sulfate. Byproduct is oxygen. And the second one is I minus to I2. So here in I minus to I2, you have to add potassium. I minus is potassium iodide solution. So I minus plus water plus ozone. I minus to O2, so iodine. And oxygen will be formed and byproduct is OH minus. This much you should learn. And before writing the equation, what I said, you learn. I will say once more, along with me, you learn. The equations are for oxidizing properties of ozone. Okay, so you have to first say two equations are there. The first one, PbS, lead sulfide to lead sulfate, PbSO4, and byproduct is oxygen. Second one is potassium iodide. Iodide, they wrote it in ionic form, I minus. And that potassium iodide is a solid, you know that. And so water is required, I minus plus water plus ozone. I minus is converted to iodine and ozone is converted to oxygen. Because water is added, so OH minus. Clear? We will write the equation. So first one, lead sulfide to lead sulfate. So the changes. This will become lead sulfate and ozone becomes oxygen, isn't it? And so here, six, you have to put this only, simple. And the next one is I minus, and I said solution, so water, plus ozone. So I minus will become iodine, ozone becomes oxygen, and then water is there, so OH minus. So you have to see here 4 oxygen, so 2 plus 2, 4. Isn't it? You see this, and first you tell yourself this will happen, this is happening, and this will change to that, ozone will change to that, so water is there, so OH minus. Clear? And practice both equations.
Ma'am,
Yes, Anand.
ozone can also act as a bleaching agent, right?
Sulfur dioxide acts as a bleaching agent. Ozone is not. Chlorine is a bleaching agent. Sulfur dioxide is a bleaching agent.
But nascent oxygen.
Ozone, wait, bleaching oils, ivory and fluor, maybe oxidizing agents through oxidation. It is given as for bleaching oils, isn't it?
Nascent oxygen is least, that's why I asked.
Bleaching agent is, bleaching can be done either through oxidation or through reduction. So it is acting as a, what?
There was a voice glitch. Could you repeat what you said, ma'am?
Bleaching can be done in 2 ways. One by oxidation or by reduction. Okay. So in this case, ozone is acting as an oxidizing agent. So bleaching action can be due to oxidation.
Okay, ma'am.
Okay. And there is a not about ozone, the question comes between chlorine and sulfur dioxide. Question is a very frequently asked question. That time I will tell.
Okay.
Okay. So this equations learned? Equations write and learn, children? Done. So 2 equations easy only, but then you have to see each topic this equation like that. Otherwise everything together you will get confused. Done, children? We will go to the next topic. Now, the second question. Amitabh, what is the problem? Have you learned? Okay, so now coming to the next topic. Now the second equation, there is a question. The second equation is used for estimating ozone. Okay, because see, if you see that I minus iodine will be liberated, and the liberated iodine can be titrated against sodium thiosulfite. So that is acidimetry titration we learned, and 12th you will be doing permanganometry. There is another one, iodimetry. So there sodium thiosulfate is used. So iodine liberated can be titrated against sodium thiosulfate. That way we can estimate ozone. So there is, you see the in-text question, how is ozone estimated quantitatively? So you have to write the next paragraph after the equation. When ozone reacts with excess of potassium iodide solution, buffered with a borate buffer, iodine is liberated which can be titrated against a standard solution of sodium thiosulfate. This is a method for estimating ozone gas. Okay, so you understand that and learn. That is the question of the index question. How is ozone estimated? Clear? Now the next topic is depletion of ozone layer. That you know already, depletion. Two things are there from jet aeroplanes, oxides of nitrogen emitted from aeroplanes, they deplete the ozone layer. That is one reason they have given there in the book. Second reason, freons. Freons are from refrigerator or spray, aerosol spray. The freons can also deplete the ozone layer. That you know, isn't it? And the last topic is about the structure of ozone. So structure of ozone, Anand asked that I will be drawing now. Ozone is having a structure. And so in the beginning, you can see the board. So here you have to write the electrons. So in the beginning, Anand asked, is there any coordinate bond? So this is a coordinate bond. So from the electrons, we can see oxygen is having 6 electrons. Out of that 2 double bonds, it has to give 2, isn't it? And this is a coordinate bond, so it has to give 2. So remaining is 2. And this oxygen double bond, out of the 6 electrons, for double bond, it has to give 2. So 4 electrons, and here it is not giving any electron because it is a coordinate bond, isn't it? And so the next structure is so it is resonance structures of ozone. And what is the proof? This bond length, both the bond lengths are the same. And so that shows that it is a resonance hybrid of both the structures. Have you understood? So the electrons you have to show. Here it is a coordinate bond. That is why this oxygen is not giving any electron. All the 6 electrons are here. This oxygen, out of the 6, 2 it has to give for double bond. So remaining 4. This oxygen here 2 and here 2. So remaining 2. Clear? Okay, done. Any doubt on the structure of ozone? Okay. We'll go to the next topic. Okay, so the next topic is sulfur. Okay, so in the case of sulfur, there are about 20 allotropes of sulfur. There are so many allotropes, and here the main allotropes are rhombic sulfur and monoclinic sulfur. So rhombic sulfur is yellow in color, and it is the most stable allotrope of sulfur at room temperature. Okay, so this rhombic sulfur, if you heat to 369 Kelvin, it will be converted to monoclinic sulfur. So from rhombic sulfur, you will get a monoclinic sulfur. And so if you heat to 369 Kelvin, you will get a monoclinic sulfur. Rhombic sulfur is called alpha sulfur, and monoclinic sulfur is called beta sulfur. And they have
Rhombic in the sense rhombohedral structure, ma'am.
Structure is S8, yes. So, and let's see, even monoclinic also S8. They have given the puckered string structure. So That is, and then they have, you can have sulfur in S6, you can have sulfur in S2, also in the vapor phase, it partially exists as S2. That is also a board question. I will come to that later. So from rhombic sulfur, you can get monoclinic sulfur. So you have to heat it to 369 Kelvin. That is why in the book they said by melting rhombic sulfur in a crucible, you melt, and then when you melt, a crust will be formed on the surface. Then you drill 2 holes and remove whatever liquid inside. Then you will see needle-shaped crystals of monoclinic sulfur. Okay, so that they have given in the book, how you will get a monoclinic sulfur. And as I said, there are many allotropic forms. And the structure S8, it is having a crown-like structure. You can see the diagram. And so it is having a puckered crown-like structure. And we can have S2, even though in the give reason question we said sulfur is existing as S8, but in the vapor phase it is possible S2, and that is paramagnetic like oxygen. That is the question. Answer also they have given. Why? When is it possible to have a sulfur, paramagnetic sulfur? Yes, in the vapor phase sulfur exists partially as S2 molecule, and due to the presence of unpaired electrons in the antibonding molecular orbital, it is having paramagnetic property. Okay, so that is the most important question in this topic. So that which form of, all of you learned that in the box it is given, which form of sulfur shows paramagnetic behavior. In the vapor state, sulfur partly exists as S2 molecules, which has 2 unpaired electrons in the antibonding pi star orbitals and hence exhibit paramagnetism. Okay. Then what are the questions about rhombic and monoclinic, the conversion, 369 Kelvin. And so they have explained monoclinic sulfur, beta sulfur. In that paragraph they have explained. I said, first you have to melt, a crust will be formed, you drill 2 holes and remove the liquid from the liquid through the crust, and remove the crust, you will get a needle shaped monoclinic sulfur. That is it. And then shape. So both monoclinic and rhombic have S8 molecules, and so the shape, you draw the first shape you learn. Okay. Transition temperature is 369 Kelvin. What is transition temperature? One form of sulfur is converted to another form, isn't it? So transition temperature is temperature at which rhombic sulfur is converted to monoclinic sulfur. That is transition temperature. Clear? So that is about sulfur, allotropic forms of sulfur. And so sulfur dioxide. Methods of preparation I can take sulfur dioxide. This is again another important compound. Sulfur dioxide, sulfur, burning sulfur in oxygen, you leave that. You cannot say that if they ask the method of preparation. And so the first method of preparation is from sulfite, sodium sulfate, by treating with any acid. So you will get sulfur dioxide. So that, and then another is from ores, sulfide ores, you can get a sulfur dioxide on roasting. So the sulfide ore given in the book is iron pyrite. That these 2 equations I will write, and then we can, I think that much only we can do. So the first one is from sulfite, any sulfite. So sulfite, ITE, so it will be SO3, 2 minus. Sulfate is SO4, isn't it? Reacts with acid. So you will get sulfur dioxide, remaining will be water, you can guess, isn't it? So 2H plus. This is the first one. And the second one is from sulfide ore. So I said, there in the book they have given, this is iron pyrite. This ore, iron pyrite, by roasting. Okay, so you will get Fe2O3 plus sulfur dioxide, 11 oxygen ion, 8 and 2. So here also two numbers you learn, it is easy. These are the two. So the sulfide ore, it is not FeS, it is FeS2, iron pyrite. This is an ore of iron and this on roasting. And so learn these two equations. After learning, I want you to write 6 equations. Okay, so aluminium oxide equation, if you can write 6 equations, you are good in inorganic chemistry. One is aluminium oxide, then we learn ozone oxidizing property and this too. Let me see who does that. First you learn this and 6 equations. The other equations are simple, ozone decomposition, ozone formation, isn't it? I want 6 equations. If you can write, you are good. Without seeing. You are brilliant in inorganic. Write again, Prashant. How many times you can write? 6, let me see. Before. All 6 you wrote, Prashant. That is very good. All 6 you wrote. Iron pyrite. Okay, that is also good. Write now all 6. Prashant, good. And let me see who writes first. All the 6. Balanced. Done, children? If you have not, then learn and properly learn and come. And I think it is time for us to leave. Okay. Idris, you saw the board? Okay. So, children, bye for today then. Learn
Ma'am.
properly. Yes, Anand.
Ma'am, that webinar is there, right?
Huh?
Webinar, ma'am. Should everybody attend it?
That ma'am is saying. I don't know. She's saying you have to attend.
Then what about our
Okay.
CS class, ma'am?
Which class?
CS.
CS. You ask sir what to do. Okay.
Okay, ma'am.
Okay, children. Bye.
Hi, ma'am.